So, welcome guys. This is the next video following up with our coordinate geometry. This video is based on a chapter 8, which is Introduction to Trigonometry, right? I had told you I will be having this chapter pretty soon. This is one of the most important chapters of this entire video series, or you can say your syllabus, because this chapter will be including in your class 11, class 12 also. So, you have to keep in mind that you have to understand this chapter with your whole heart. You have to pay more attention to this chapter than any other chapter, because this chapter will be including whatever you have learned previously till here. That means you will be understanding each and everything regarding your triangles. You will be learning certain new things in this. Then you will be following this chapter up to your chapter 9, where we will be understanding that how exactly is trigonometry used in our daily life. From there we will be keeping this up to our circles, and then we are going to use that in our area related to circle, and my mensuration chapter 13, which is surface area and volumes. So this chapter will be included in at least 3 to 4 chapters which are related to this one, but they are entirely different. They will be having certain concepts that we are going to study in this. So always remember, you cannot skip this chapter. So I will be recommending you guys to write each and everything down that I tell you in this video, and make a proper notes of this chapter, especially this one and the one we are going to do after this, which will be your circles. So you have to make proper notes of each and everything. So with that being said, take out your pens and notebooks, and we are going to do certain sums today. Although I will be telling you each and everything, but I will be recommending you guys, once you have understood the concept, try to do sums on your own, since this is a totally new topic to you. So I will be explaining it. Firstly, I will be explaining it, then I will be encouraging you guys to understand, to do that sum before me or even with me. So with that being said, let us see what actually this chapter is. So before starting this chapter, let's find out what this chapter truly is based on. See, you guys already understand what triangles are, right? Triangles are what? They are a shape which has three sides, right? Now on the basis of their sides, they can be of three types. That means they can be a scalene, an isosceles, or an equilateral, right? Scalene with 0 side equal, isosceles with 2 sides equal, equilateral with 3 sides equal. So this is the case of sides. Let's say I tell you on the basis of angles. Now guys, see, I can have what? A right angle triangle, right? In which it will be an angle of 90°. An equilateral triangle in which what? All the angles are what? 60 degrees, right? And I can have an acute angle triangle, right? Acute angle triangle is what? In which all angles are less than 90. Let's say 81, let's say 81 also, and I will be having what? A 62. Let's say this one is 18 degrees, right? So it should be like this. Now guys, see, there can be an obtuse angle also. Obtuse angle will be what? A triangle in which at least one angle is obtuse. Exactly one will be obtuse, no more than that. So let's say if this is 91, let's say this is 91, then let's say it is I have a difference of 89, so let's say this is 49 and this is 40. So this will be what? This will be an obtuse angle triangle, right? Now you guys, see, in this chapter we are going to focus on our right angle triangles, primarily on right angle triangles. But always remember, trigonometry does not end with right angle triangles. It is not totally based on right angle triangle. We can apply trigonometry everywhere, right? We can use that in either right angle triangle, in isosceles, in equilateral, in scalene also. So I will be explaining how we will be using our trigonometry in every kind of triangle, but majorly in this chapter we are going to be focusing on only right angles. So once we have finished this video, once we have understood the basic concepts of your NCERT, I will be telling you how to use trigonometry in our what? In our other triangles also. But for now, let's focus on this right angle triangle. So see, what do we have? A right angle triangle has what? An angle which is 90. Side opposite to that angle is what? It is your hypotenuse, right? Now, if this is the case, your trigonometries will always be applicable on the other two angles, either of the other two. That means either it can be applicable on this one or it can be applicable on this one. Now guys, see, if this angle is theta and this angle is phi, so either you can apply your trigonometric functions on this. That means actually I will be explaining what trigonometry function is. For now, just understand this and skip this one. I will be explaining it later on, else you will be getting confused. Let's just understand the basic things that happen in a right angle triangle. This is your hypotenuse. The angle which is this angle is on which arm? That will be one your base and another one will be your perpendicular. The general formula is this: the longest side is what? Longest side is your hypotenuse. Second longer, it is what? It is your perpendicular. And your least is what? It is your base. Now guys, remember in in perpendicular triangles, I can apply Pythagoras theorem, which will give me what? Hypotenuse square, which is equal to perpendicular square and base square, right? Now you guys see, I can calculate the sides using this formula, but that is depended on when we have 2 out of 3 sides given, right? If I tell you, if I have given you the perpendicular and I have given you the base, you can easily calculate the hypotenuse, provided that triangle is a right angle, right? Now let's consider this. I have a right angle triangle. I do have a right angle triangle, but I don't have is the second side. I only have given you the one. Let's say I've given you the base, which is 5 centimeter, and I ask you to find me the perpendicular and find me the hypotenuse. Now in this case, you guys will be telling that we cannot use only one value in our Pythagoras theorem and find out the other twos, because we have already understood, we have already learned this. We have every time been told that there should be 2 sides to calculate the third one using the Pythagoras theorem. But what if I tell you we can use only one side and we can find out the other two? Henceforth, the need of trigonometry came to existence. We will be doing what? We will be considering any of these two angles right here, either this angle phi or this angle theta. We will be having certain trigonometric functions which will be having certain values at given angles. Those values will be what? Those values will be the ratios between our sides. That means if I find out the ratio between perpendicular and hypotenuse, this will be a function of, it will be a trigonometric function. We will be calling it a sine, followed by an angle which is theta. Either sine can be this one or that one. But remember this, whichever angle we are using, the side opposite to that angle will be considered the perpendicular, and the angle which is the angle is on which side, that will be considered the base. So this one will be base, this one will be perpendicular. But if we had to find out sine phi, so it should be considering this one as my perpendicular and that one as my base. From here I can calculate each and every side with only one side given. So remember this, there are certain ratios which are fixed in the case of right angle triangle. We are going to study later on in this video, but for now remember this, trigonometric functions are used when we have to calculate distances. Now distances are not limited in the case of just a triangle which is drawn on a figure. Let's say if you are standing in front of any building, you guys know the distance between you and that building is, let's say, x meters, and the angle from which you are looking at the top of the building, it is, let's say, 60 degrees. You have to find out the height of the building. Now you won't be going there with your measuring tape and just measuring your whole height, will you be? You won't be, obviously. So if that will be the case, then we will be using our trigonometric functions in order to calculate the height of the building. So this is the case. Now I will be having the examples where I use this one, but for now remember this, the triangles topic is very important in this, especially a right angle triangle. So I hope you have understood the case, right? So let's start with the video. So this is my introduction to the chapter. What is trigonometry? Trigonometry is derived from a Greek word. It is derived from a Greek word, that means from the word which originates from Greece. It has 3 different parts: tri, gono and metry. or you can say trigonometry. See, tri is what? Tri means 3, gon means side, and metron means measurement. So we are going to do what? We are going to measure the 3 sides related to any triangle, but in our case it will be a right angle triangle. I will be finding out the relation between those. I will be finding out the ratios. Using those ratios, I will be doing what? I will be finding out the values which are remaining. So remember this, tri means 3, con means side, and metron means measurement. So measurement of 3 sides. Now let's see what do we have. So applications of trigonometry in real life. See, you guys remember if I had given you an example that you were standing in front of a building, you had to calculate the height of the building. It will be impossible because you won't be taking the measuring tape to measure it. That will be impossible, but using trigonometry, we can almost find out distance between any two things. Let's say if I'm standing in front of the Mount Everest, so I will be using trigonometry there as well. I will be calculating the height of the Mount Everest also. Let's say I'm standing in front of a tall tree. Let's say this is the tall tree. I'm standing in front of it. I'm looking at the top of the tree. I know the distance between me and the tree is certain value. Let's say it is x, and the angle is certain angle which is theta. I can easily calculate the height of the tree. See, triangles are very easy to have in a real life. We can just stand in front of anything with our eyes fixed at a particular point, and the distance between us and the height of the building or anything which will be forming a triangle. It will be a right angle triangle, but it can be any other triangle also. Let's say if this was the case. Let's say there was a pole, I was standing here and my friend was standing here. I was looking at the pole with different angle, my friend was looking at the pole with different angle, height of the pole was given. I had to find out the distance between us. We can easily calculate that. But this kind of thing will be discussed in our next chapter, where we will be using a trigonometry to find each of these things. But for now we are not going to use this one. Just remember this, where we can use them in astronomy. That means calculating the distance of stars and planets. We can use this to find radius of earth also. We can use to find the radius of, sorry, height of the hills, buildings and trees, etc. We can just navigate planes where they have to go. We can just pinpoint the locations. We can use them even defense system. That means we can have a laser guided missiles, anything like that. So let's see if this is the case, how actually are we going to use it. So before we start, let's just go back to the historical background of this. See, the history of trigonometry dates back to the early age of Egypt and Babylon. See, in both of these regions, the trigonometry is originated. The angles were measured in degrees. That time the angles were measured in degrees, but now we can measure them in radians also. That will be studied, that will be told to you actually in your class 11. But for now, remember this, we are focusing on our degrees, but angles can be measured in pi radians also. You guys remember I told you, or somebody would have told you. If you haven't, then just wait for the area related to circle. I will be telling you this. The central angle of circle is what? It is 360, and we represent it with 2 pi. So exactly 2 pi is what? It is 360 degrees, and 90 degrees is what? It is pi by 2. So either you can write it like this or you can write it like that. Your answer will be same, but since you haven't understood the concept of your pi radians, so just understand this. At that time the angles were measured in degrees, like we are going to measure it now. So it was then advanced by the Greek astronomer Hipparchus. In the 2nd century BC, he compiled a trigonometric table that measured the length of a chord subtending various angles in a circle fixed at a radius. So he did what? Because at that time everything was calculated in degrees, we had to take our whatever the measure units, whatever the thing was, their device was there to measure the degrees. He did what? He just made a circle and started drawing chords in it. You guys will be understanding this later on with this series. I will be having those. So he did what? He just found out whatever the angle was chord subtending at the center, the different angles and everything, he measured them, and he had a trigonometric table. I will be telling you what the table is later on in this video. Using that table, we are still calculating the distances which are quite large, and we don't even have to do much of the calculations ourselves. except the finding the values of the lengths, etc. But we don't have to calculate the degrees because the table is fixed and the values are fixed. So with that being said, let's see. And you guys know he is the father of the trigonometry because obviously he had made the trigonometry easier. So he is the father of the trigonometry because he just made trigonometric table that has been used up till now. Now let's see. He did what? He's a great astronomer. He was the first Greek to develop quantitative and accurate models for the motions of sun and moon. See, he already found out the exact models for the motion of sun and moon. He just has pinpoint whatever everything was happening in a solar system, whether solar and lunar theories and his numerical trigonometry. He was probably the first to develop a reliable method to predict solar eclipse. So he did what? He exactly used our trigonometric functions and found out or even predicted the solar eclipses that were going to be take place later on in this time period. So he used exactly the motion of the sun and moon and pinpointed the time when the solar eclipse will be taking place. So he was one of the brightest astronomers of that period. Now let's see. Now this is the case. This is the right angle triangle. So you guys already know it has a hypotenuse. It has an opposite side which is what? It is perpendicular, and this is the adjacent side which is what? Base. Let's say this angle is what? The angle between hypotenuse and base is what? It is theta, and angle between hypotenuse and perpendicular is what? Let's say it is phi. Such that theta and phi are what? Complementary to each other, right? So this will be the case. This has been written here. Hypotenuse is always the opposite side of the right angle. Opposite to this one, already told you, it is the longest side in the triangle. Already you know. Adjacent leg is one other side that is adjacent to angle theta. This is your adjacent leg, or you can say your base. The opposite side to your angle theta, it is what? It is your perpendicular, or you can say your opposite side. So choice is yours, whichever way you want to go, you can use that. Now let's see, what do we have in right angle triangle. See, if we just change the perspective of the angles, let's say angle theta was at C, then theta will be having the C, this will be the perpendicular side, this will be the base, and this will be the hypotenuse. The hypotenuse is totally fixed in the right angle triangle. It is always the side which is opposite to your 90-degree angle, but bases and perpendiculars can be changed. They can be altered with respect to the angles that we are taking. If we are taking angle C, that means this is having the theta, then this will be the base and this will be the perpendicular. If theta is at A, then this will be the base and this will be the perpendicular. Always remember, the arm will be considered that side on which we have the angle between hypotenuse and that one. Let's say this is the base, right? Similarly, in this case, this was the hypotenuse and this was the base. This will be considered. So whichever angle you are taking, its adjacent arm, one will be your hypotenuse and another will be your base, considering that angle is not a right angle, it's not a right angle, and the triangle is right angle triangle. So I hope you have understood the case, right? So let's see, what do we have now? So application is what? To find the height of a clock tower and a tree. Let's say this is the clock tower and this is the tree, and let's say this is certain point mn here. Let's say this is the height of anything, and at point C, I am observing what? I am observing both the top of the tree and the top of the tower. So you guys see this triangle, that means CMN is similar to what? CAB, and it is also similar to CPQ, right? This angle is common to every triangle, that means MNC, ABC, and PQC all have angle C, which is common. In triangle MNC, angle N is 90, angle B is 90, and angle Q is 90 also. That means using angle criteria, the triangles are similar. So if we just do what? If we just find out the ratios between these two, ratios between the sides of this triangle, we can use those ratios and find out the height of this one, even the height of that one, because ratios remain the same because the triangle are what? Similar. Using similarity, we can calculate height of the triangles and height of different figures if they are forming right angle triangles. This concept will be later discussed in chapter 9. But for now, remember this, we will be using trigonometry to calculate the distances of very high buildings or very high monuments or very far distances by using just ratios between their sides. I hope you understood the case, right? Now guys, see, it is here your chapter starts. This is the very important portion. Don't skip this one. See, now I have the concept of trigonometric ratios, or you can say functions. Let's consider this is a triangle A, B, C, such that this angle is 90°, this angle is alpha, and this angle is beta. Okay, let's say let ABC is the right angle triangle such that angle B is 90°, angle A is beta, and angle C is alpha. Okay, therefore you have what? AC will be what? AC will be your hypotenuse. BC will be what? It can be your base or it can be your perpendicular, depending upon which angle I'm going to choose. Similarly, AB will be what? AB can be your base or AB can be your perpendicular. Now that will be depending on if I'm considering my C as the angle or my A as the angle. If I'm considering C as the angle, then this will be the base and this will be the perpendicular. If I'm considering, sorry, I told you opposite. If I was considering C as the angle, then BC will be the base and this will be the perpendicular. If I'm considering A as the angle, then this will be the base and that will be the perpendicular. Henceforth, both of these can be either of the two. I hope you've understood the case, right? Now, since we already knew in right angle triangles what happens is we can use a Pythagoras theorem, right? We can use Pythagoras theorem. So I will be having what? AC square will be equal to what? It will be equal to AB square plus BC square, right? Now you guys see, this is the case when I have two sides given. When there are not two sides given, what to do? What we did, or what the mathematicians did, they did what? They just tried to find out the relation between each of the perpendiculars, base and height, each of these three. So they did what? They firstly chose their P, divided with the hypotenuse, and named this ratio to be the sine theta. Now theta can be any angle, it can be the alpha or beta, but they did what? They picked up their perpendicular, they picked up their hypotenuse, and they picked up their base in general, named the ratio perpendicular upon hypotenuse to be the sine theta. Later they did what? They just took their base, divided it with the hypotenuse, and they thus did what? They named this figure to be, they named this ratio to be cos theta. Then they did what? They divided both of these values too. So they divided perpendicular upon hypotenuse with base upon hypotenuse. It cancelled down and it got what? It got perpendicular upon base, and they named this one to be what? They named this one to be tan theta. Now every other trigonometric ratio is dependent upon this. See, they did what? Firstly, they took perpendicular and divided with hypotenuse. They got an angle which was of sine. Then they did what? They took base, divided with hypotenuse. They got an angle which was of cos. Later they divided perpendicular and base. They got the ratio which was tan theta. Right? Now they did what? They just, some of them thought it would be better if we just divide hypotenuse with perpendicular, because hypotenuse is the greatest answer. It is the greatest side, so it should be giving me a answer which should be greater. It will not be much in decimal. So they did what? They just found out the ratio between hypotenuse and perpendicular. They named this one to be what? They named this one to be cosecant theta, and they later found out it was same as 1 over cosecant theta was same as my sine theta. Right? If I reciprocal this, I will be having what? Perpendicular upon hypotenuse. So they did what? They understood this, that sine theta into 1 over actually sine theta into cos theta. That means sine theta into cosecant theta is what? It is 1. That means this is the inverse of that one and that is the inverse of this one. Understood? Later they did what? They did the same thing with what? Base and the hypotenuse. So they tried to do what? They tried to find out the ratio between hypotenuse and base. So they did what? Divided hypotenuse with base. They named this one to be the secant theta. Later they found out that 1 over secant theta is same as my cos theta. So that means cos theta and secant theta are multiplicative inverse of another. So that means their product should be giving me 1, right? And lastly they did what? They exactly did find out the ratio between the base and the base and the perpendicular now. So because they already knew perpendicular upon base was the ratio, they did what? They just inverted that base upon perpendicular and named this one to be the cot theta. Later they already found this out that 1 over cot theta was same as my tan theta, right? Which was exactly same as my sin theta over cos theta, right? This is how we got the tan theta, right? So that means tan theta into cot theta will always be what? It will always be 1. Where adjust the hint is what? It is this one, that tan theta is equal to what? It is sin theta over cos theta. Then cot theta will be what? It will be equal to cos theta over sin theta, right? That will be the case. Because we can divide it like this, base over hypotenuse divided by perpendicular hypotenuse. This will cancel out. I will be having what? Base upon perpendicular, which is what? Cot theta. So in short, after I just put, if I want to learn each and everything, I had a table which was the trigonometric ratio table. Let's just understand that one. Then we'll begin with the trigonometric identities. So you guys see, I already know this. Sin theta is what? It is perpendicular upon hypotenuse. Cos theta is what? It is perpendicular, base upon hypotenuse. And tan theta is what? Tan theta is perpendicular upon base. Cot theta is inverse of that, is it is base upon perpendicular. Secant theta is what? It is hypotenuse upon base. And cosecant theta is what? Hypotenuse upon perpendicular. So if I just make a table out of this, you guys see, this is the trigonometric ratio table. So if you want to learn this, you can learn with any of the tricks. Let's say Param buys pens, Hari has let's say balloons. So this will be the case, you guys see, PPP, PBP, HHB. This will be ratio of these two will be giving you sin theta, and inverse of that will be giving you cosecant theta. Ratio of these two will be giving you cos theta, inverse of that will be what? Secant theta. Ratio of these two will be tan theta, inverse of that will be cot theta. So this is the value chart where you can learn this one, or if you have understood each and every concept, so that is totally up to you. Although you can just make this table and learn this, write it down, write as many times as you can till you have learned this concept. Now with that being said, I hope you have understood the case. Now let's see what do we have next. Now is the case of trigonometric identity. This is very, very, very important. The reason I'm calling it very, very, very important, because you are not giving up those identities for your life. You will be using them in every aspect once you are provided that you are taking your mathematics in 11 and 12. Then you have to understand these identities. You have to learn these identities. Now guys, see, if I take my right angle triangle, the one we have already taken, the earlier one, let's say this is the right angle triangle, which is what? ABC. This angle is 90, and I'm going to consider this this angle right here, which is theta. Okay, if this is theta, then this will be what? Perpendicular. This will be what? Base, and this will be what? Hypotenuse, right? I know perpendicular square plus base square is what? Hypotenuse, right? So if I just do what? If I divide both sides with h square, I will be having what? E square over h square, b square over h square equals to h square over h square. This will be cancelling out. Can I write it like this? E over h, square of that, and b over h square of that equals to 1. Now, if you guys remember, if I just make the table once again, P, B, P, H, H, P. If you guys remember, this is what? Sin theta. This is cos theta. This is tan theta. Opposite of that, cot theta, secant theta, secant theta. Now you guys see perpendicular upon hypotenuse is what? Is sin theta. So can I write it like this? Sin theta square of that plus base upon hypotenuse is what? It is cos theta square of that, which is equal to what? A 1. Now you guys see, while you square trigonometric functions, their values are squared, the functions are not. That means whatever the value of sin theta is, I can square that one, but if we have to square this one, we will be writing it like this. Sin square theta plus, same goes for here, cos square theta, which is equal to what? 1. What I'm trying to tell you, just don't put a square over theta, we have to put the square over sine function. So this is your first identity, which tells you that if the angles are same, then square of its sine function, square of its cos function, your value will be what? It will be 1. This is the identity number 1. I'm just going to mark it here. This is your identity 1. Now let's say if I just erase this one, if I do what? This was the case, p square plus b square equals to h square, right? Now what I do what? I divide everything with p. Divide both sides with p square. I will be having what? Let's see. P square by p square plus p square by p square equals to h square by p square. That means this will be 1. It can be written like this, base upon perpendicular square of that. It can be written like this, hypotenuse upon perpendicular square of that. Now guys see, base upon perpendicular is cot theta, hypotenuse upon perpendicular, it is what? Cosecant theta, right? That will be the case. If I just erase this, I will be having what? Let's see. So I had what? I had this one where 1 was equal to what? 1 was equal to, 1 plus base upon perpendicular, right? That means cot square theta, which was same as what? Hypotenuse over perpendicular, it was what? Cosecant square theta. That means cosecant square theta minus cot square theta. It is what? It is 1. This is your identity number 2. First identity is sin square theta plus cos square theta. It is 1. Second identity is what? Cosecant square theta minus cot square theta. It is what? It is 1. Right? Now let's see. I have divided with hypotenuse. I have divided with what? I have divided with perpendicular. Now I am left with what? I am going to divide it with what? My bases. So this was my second identity, which was what? Cosecant square theta minus cot square theta. It was what? It was 1. Right? Now thirdly, I know p square plus b square equals to h square. Right? Now I'm going to divide it with, divide by b square. So you have what? b square, b square, b square. This will be cancelling out. Hypotenuse upon base, it is what? Secant theta. So I can write it like this, secant square theta. This will be a 1 here. Perpendicular upon base, it is tan theta. So it will be what? Tan square theta plus 1, which is equal to secant square theta, or you can say secant square theta minus tan square theta equals to 1. So you have your 3 identities, which are what? If I just erase them and write them once again. So my 3 identities are what? They are sin square theta plus cos square theta 1, then secant square theta minus tan square theta equals to 1, then cosecant square theta minus cot square theta. So these are the 3 identities that we are going to use later in this chapter, but I wanted to tell them earlier so you can learn them and then you can understand what we have to do in later on in this video. Although there will be some formulas also, so I will be explaining those values later on. But for now, these identities are the part of the concepts I have taught you. Those are also the part of the concept, but they are not related here. We will be needing them towards the end of the video, so I will be having a slide later on in this video where I will be explaining those concepts to you. But for now, this is the case. These are the ratios between the sides and the respective trigonometric function. These are the identities using your Pythagoras theorem. So let's see what do we have next. So I have the example now. It is what? If sine theta is what? It is 7 by 25. Find the other trigonometric functions. Now you guys see the theta angle is here. Then this will be your perpendicular, this will be your base, and this will be your hypotenuse. Right? So if this is the case, you guys see sine theta is what? 7 upon 25. It is actually what? It is actually perpendicular upon hypotenuse. So your perpendicular is what? Let's say the ratio is 7, so it is 7 centimeter, or you can say 7k centimeter. It does not matter. Let's say it is 7k. Your hypotenuse is what? It is 25k. So base will be what? It will be square root of 25k square of that minus 7k square of that. So it will be what? Square root 625 k square minus 49k. So that will be what? It will be 576 k square, which will be what? 24k. So base is what? It is 24k. That means if sine theta was sine theta was 7 by 25, this was 7k, this was 24k, and this was 25k. So I have to find out what? I have to find out cos theta. Cos theta is what? Let's make a table. PVP HHP. Cos theta is what? It is based upon hypotenuse. That means 24k by 25k. It will be what? 24 by 25. Then tan theta is what? Tan theta is perpendicular upon base, or dividing both of these values. Perpendicular is 7k, base is 24k. Divide both of the values, you will be getting what? 7 by 24. So tan theta is this one. I have to find out what? Cosecant theta. Cosecant theta is 1 over sine theta. So I can simply write it like this. 25 over 7. Or you guys say it is hypotenuse upon perpendicular. That will be the case. Secant theta, it is inverse of cos theta. So I can write it like this. 25 by 24. Or you can see it is what? Hypotenuse upon base. And cot theta will be what? It will be reciprocal of this one. That means 24 by 7. So these are the all other trigonometric ratios that we had to find out. I hope you've understood the case and you don't have any doubt in this, right? Now let's see what do we have next. It is this: using the given figure, find all the trigonometric ratios for angle A and B. Firstly, I have to consider this angle, then I have to consider that one. Now you guys see, if angle is A, then this will be base, this will be what? This will be perpendicular. So sin A will be what? It will be perpendicular upon hypotenuse. That means 5 over 13. Cos A will be what? It will be 12 over 13 because base over hypotenuse, right? Then if I just go with tan A will be what? 5 over 12 because perpendicular upon base. Then cosecant A will be what? Reverse of this one, 13 by 5. Secant A will be what? Reverse of that one, 13 by 12. Cot A will be what? Reverse of that one, 12 by 5. So these are the values if the angle was at A. Now let's see if the angle was at B. If I just erase this one. Now if B is the angle, if angle is at B, then I have what? Let's see. This will be perpendicular, this will be base, and that will be hypotenuse. So sin B will be what? It will be 12 by 13. Cos B will be what? It will be 5 by 13. Secant A will be what? Sorry, tan A will be what? Sorry, tan B tan B will be what? It will be perpendicular upon base, that means 12 by 5, right? So secant A will be what? Secant B, it will be what? 13 by 5. So secant B will be what? It will be 13 by 12. And cot B will be what? It will be 5 by 12. So these are the trigonometric ratios if angles are at A and B. So you can find out the ratios using this. So I hope you have understood the case, right? This is how you're going to calculate the ratios. Now let's see what do we have next. It is this one. Given tan A, let's say this is the case. A, B, C. This is the tan A, which is what? 4 by 3. That means this is 4, this is 3. I have to find this one. So tan A is given to me, it is what? 4 by 3. Now you guys remember this is a Pythagorean triplet. This should be a 5. If you don't, just assume this to be a perpendicular, this to be a base. Then p square plus b square equals to what? H square. That means 16 plus 9 equals to h square. H will be what? Square root 25, which will be what? 5. Since we don't have any measurement, so it should be a 5 only. So I have what? I have my perpendicular, which is 4. I have my base, which is 3. And I have my hypotenuse, which is 5. So let's say this was the triangle ABC. This is 3, this is 4, this is 5. So I have to find out sin A. Sin A will be what? Perpendicular upon hypotenuse. That means 4 by 5. I have to find out cos A. Cos A is what? It is base upon hypotenuse, which is what? 3 by 5. And then I have what? Tan A is already given, so I am going to find out secant A, which is what? Inverse of that one, that means 5 by 3. Cosecant A, inverse of that one, that means 5 by 4. And lastly, I have what? Cot A, which will be what? Inverse of this one, that means my tan one, it will be what? 3 by 4. So these all are my trigonometric functions if the angle was at A. I hope you have understood the case and you don't have any doubt in this question. This is how you are going to find out the values of other trigonometric ratios or trigonometric functions. Now let's see what do we have next.